All right, good afternoon, everybody. This is Matt Gross in the afternoon of Saturday, September 1st, 2018. Just want to take a quick look here at the tropics and Tropical Storm Florence in particular, and some of the possible scenarios down the road as far as what might happen here, because we got an interesting 500 millibar scenario where this storm could either be nothing and be totally forgotten, or could become something very, very interesting in about a week's time. So let's look at the particulars here to start off from the National Hurricane Center. Right now, they've got it at 14.8 north, 27.8 west. Maximum sustained winds only 45 miles an hour, so it's a weak system. And perhaps one of the more interesting notes here right now is that it's only moving to the west-northwest at about 14 miles an hour, which is not all that fast for a system that is in the far eastern Atlantic. Many times you see these systems that are this far east moving at 20, 25 miles an hour before they, kind of slow down in the middle of the basin. That's not the case here. It's already moving very slowly, which means it's going to take a long time to make it across the Atlantic or up into the North Atlantic, depending on wherever it goes. But we could be dealing with this for a while. Right now, the National Hurricane Center does not make this a hurricane through day 5. That's an important note. I'm going to show you why a little bit later. And they're kind of hedging their bet in terms of which way it's going to go. They kind of have it going right up to a crossroads, which is going to occur somewhere in this area. Or really, they haven't really hedged the bet yet. That might not be fair because it hasn't really gotten to the point of interest, which is around day 6 or day 7. But it's moving right into this area where it's going to basically hit a fork in the road, and it's going to go one way or the other. And I'm going to use the last two European model runs of OZ last night and 12Z today to kind of show those two possibilities. So first of all, this is OZ last night. This is the older run, and then this right here is going to be 12Z, the newer run today. So this is at 500 millibar. This is the middle of the atmosphere, so to speak, as far as where hurricanes can get steered. Remember, they're steered at all different points of the atmosphere. The lower levels got 850, the mid levels here 500, and then way up in the atmosphere 200 or 300 millibar, which we'll get in a second. But these 500 millibar maps made by Levi Cohen on the Tropical Tidbit site are very, very helpful, and they show it nicely, and it's kind of a split between the upper and lower levels, so it's a good model to use. So we're going to go out here to about day 5 and show you, this is, remember, where the National Hurricane Center still has a tropical storm somewhere in this area right over here. It's very, very weak, so it doesn't show up on the 500 millibar maps, but we don't really care about that at this point because what we care about is this decaying ridge right here. And as this ridge decays in front of it, it's going to open up a path to the north where Tropical Storm Florence, as it starts to develop, you see now it appears here at day 6 on the 500 millibar. It's starting to get a little bit stronger, and will open up a path for it to turn toward the north. You see now the ridge by day 7 has completely decayed. This feature up here in eastern Canada, eastern Quebec, is coming down and has split the ridge that's down over here, which basically allows a path straight to the north-northwest, just to the east of Bermuda, which would likely allow the storm to escape. And if you watch what happens beyond this point, is run it forward to day 8 and then day 9, the ridge starts to build back in at day 9. As you see, the storm intensifies quite a bit in these 48 hours. Once you get into the western Atlantic, conditions become more favorable. But the ridge does try to build back in and trap the storm in this area. Now, normally what happens when you get a storm this far north in latitude, when a ridge builds in, you see it building off to the east here. Run ends at day 10, so you don't know what would happen beyond this point. But normally, and we saw this with Hurricane Jose last year, would be a very good example. Normally, a ridge will build around the storm, and it will stall. The steering currents will weaken. We don't know if that would necessarily happen here in this particular depiction with Florence and the Euro here at 12Z, but it's usually very, very hard to get systems this far to the north to turn back to the west because the ridge will usually form around them instead of over the top of them. So in this case, Florence was a little bit further north, and the ridge was a little bit late in building. And therefore, you end up with a storm that probably would have stalled out in this area and either gone out to sea. Maybe it would have snuck up into Canada. Again, we don't know. The run ended. But it probably was not going to hit the east coast of the United States, at least not south of, let's say, this point. But if we go back to last night's Euro run, we see a slightly different scenario. And this shows you how these 500 millibar maps are very, very key in determining what will happen. So if we run this out to day 6 last night, you see a much more impressive ridge here with the 591 line encompassing a large portion of the Eastern Atlantic. I'm going to go compare it here to 12Z. Now, unfortunately, this is day 6 here. It's 24-hour increments on these maps, so you can't compare a 12Z run to an OZ run at the same hour. You kind of have to dance around the 12-hour images. So this is day 6, Friday at 12Z from today's run. So this is Friday morning to Saturday morning. You see not much of a ridge here in the North Atlantic. This piece coming down. And then this is Friday night right here in between. So even though we don't have the exact model images to compare, we can clearly see that the ridge that builds back in is much, much stronger last night on the OZ Euro than it was at 12Z. And the reason why this is significant is as you run this forward here, when the ridge decays at this point, this system up here in eastern Quebec does not dive down as far south as it does today at 12Z. So again, this is day 8. This is Saturday night / overnight Sunday morning. This is last night, and then compare that again to today at the same hour, or the same general time frame. We don't have the exact same hour. This is Sunday morning. So this right here is today. This is last night's run, excuse me, at Saturday night / early Sunday morning. This is now Sunday morning of today's run. And what you notice here is that, again, this is 12 hours later, so it's hard, again, to compare exactly. But you see this piece of energy is much larger today at the 12Z run than it was last night. And what you see last night, particularly, is this ridge over here moving to the east much faster and ready to build in over the top of what is now Hurricane Florence, where it appears on this map. So I'm going to run it backwards 12 hours. Again, this is last night's run to here, where this is in Canada, and watch how it pushes east very, very quickly, forcing this system to depart much further to the east instead of diving down and possibly picking the storm up. And then as we move towards day 9 last night, this ridge starts to build over the top. Look how the hurricane here in these previous images is here. It moves northwest at day 8, and then when the ridge moves back in, boom, it turns back to the west at day 9. And this is where you end up with the big time scenario, where run it forward to day 10. Now you've got a rapidly intensifying hurricane, huge ridge building over the top, and this would extrapolate it out again. It ends at day 10, but extrapolate it day out. This would be a major, major hit somewhere on the East Coast, probably in the southeast United States, or it might have turned up into the Mid-Atlantic if the ridge continued to move to the west and it kind of went around it up the western side. But either way, this is a very, very big scenario that would yield a very, very big hit. Again, we don't know what's going to happen. Both of these scenarios are very, very plausible, but the idea here that's very, very important is that when the hurricane gets to this area, just as it's a tropical storm, I should say, because it's not going to be a hurricane at this point, gets to this general area, that is where you're going to have a crossroads. The storm might stay weaker and just go right out into the middle of nowhere, in the middle of the North Atlantic, and be totally forgotten, a fish storm that you never hear from again. Or it could get trapped underneath a newly building ridge here in the western Atlantic, which would then force the storm back towards the west, and it would probably be intensifying when it did that. This is a this is a fork in the road scenario. This is not, oh, it might go 200 miles this way or 200 miles that way. Eventually it will, because it's 10 days out. Right now we're dealing with a thousands of miles error. But it's right in this area here that you have a very, very significant cross in the road. And that's what the real game is, or you're trying to figure out around this day 5, day 6, because that's ultimately going to determine whether this is a forgotten little system that you don't really care about, or if it's something that could be very, very significant in a week's time. One of the really, if you want to go to a really, really extreme scenario in terms of, you know, a storm hitting a fork in the road that could have been absolutely nothing but ended up being a really, really big system, it's actually Hurricane Andrew. I'll pull up Hurricane Andrew's map here, and you can see how Andrew developed in the eastern Atlantic here and was really a disorganized tropical storm for a very, very long time, was turning north. Look how far north it is here. It was already at about 25 north, 65 west. Most storms in this spot go out to sea. And then Andrew hit a very, very significant crossroads. There was an upper level low when it was coming into about this area here, northwest of the islands, or northeast of the islands. And that system tried to pick it up and would have turned it out to sea. But Andrew remained just weak enough to miss that connection, and then a high built in over the top, and it turned back to the west. And notice, very, very importantly here, how fast Andrew went from this green color here to a tropical storm into a Category 5 hurricane. This is why it's so significant whether or not this system can get underneath that ridge, because when hurricanes or tropical systems get under ridges in the western Atlantic, they tend to develop very, very quickly. And that's what Andrew got. I wouldn't expect anything like this, but it's just an extreme example to show you what can happen when a storm gets underneath a ridge like that. If you look at Andrew, this is what some of the models were showing with Andrew when it was just to the northeast of the island. You see, most of them had it turning to the north because they had it either getting just strong enough to be picked up by this upper level low, or the upper level low digging a little more than it actually did. And you can see how this storm very easily could have turned to the north. It would not have rapidly intensified if it took this direction, and you wouldn't, and Andrew in 1992 wouldn't have even been a footnote in history. It would have been totally forgotten. Then as we move a little bit further forward in time, you can see how the crossroads scenario really started to develop, even when it was only a day or so. Look at this, 24 hours out. Again, models weren't as good in 1992, but you can see how distinct this fork in the road is. Now, obviously, even these models that went to the west were not far enough to the south in terms of how big the high was going to build over the top. But you can see how this is a very either-or scenario. This is not, it might go 100 miles this way, 100 miles that way. It's a fork in the road. And one more thing I want to show you here, and this is with the GFS and why the intensity of the storm is going to matter. Now, I'm going to use the GFS because it allows us to take a sounding, and this is at day 4, so about 24, 48 hours ahead of the crossroads. And I'm going to take a sounding from around the storm in the general area that it's moving. And this will download. And one thing we notice here, you don't have to pay any attention to this over here. Pay attention to this area over here, this vertically stacked column. What this shows you is it shows you the direction the winds are blowing at different points in the atmosphere. And down here, this is the lower part of the atmosphere. You see all the winds are out of the east. These are all trying to push the storm to the west. Then as you get up here, you've got some light wind to the east. You've got some wind in the upper level atmosphere trying to push the system to the north and northeast, so it's out of the southwest. And all of these different points in the atmosphere are competing with each other, trying to push the storm in different directions. Now, a couple of things to note. Number one is that this is also an indication of some shear. Now, none of the winds at any level of the atmosphere are really, really, really strong, so there'll be wind shear, but it won't be extremely strong. But normally, systems they want to develop like it when all the winds at all levels of the atmosphere are blowing in the same direction. We do not see that here. We see easterly winds over here. We see southerly winds over here. So it's hard to tell exactly which way the storm is going to move. And secondly is that typically, not always, but typically, the stronger the storm is, the more likely it's to be steered by conditions at the higher points of the atmosphere. Now, all tropical systems are always steered by all levels of the atmosphere, but it's particularly steered by, but stronger storms are steered more by the upper level of the atmosphere. Weaker storms are steered more by the lower level of the atmosphere. So if Florence stays weaker, oddly enough, it will be more likely to be steered by these winds trying to push it to the west, which means that it's more likely to be further south, which means that if the high builds up, again, we don't know when, if that new high is going to build back in the Northwest Atlantic, but if it does develop, a weaker Florence early on, much like a weak tropical storm Andrew early on, is more likely to turn back towards the west than a system that develops quicker and turns into a hurricane. Now, the GFS has developed Florence into a hurricane more often, so therefore it's shown more out-to-sea solutions. But really, right now, these early runs these early days is going to determine how strong it gets, and that's ultimately going to have a very, very big impact on where it goes. All right, that's enough for now, but that's kind of what we're looking at. and could be an interesting week. So I'm sure we will all continue to watch it closely and see what happens. All right, that's it for now.